Our first speaker is Bruce Howe. Bruce is chair of the Joint Task Force for Smart Subsea Cables and research professor at University of Hawaii, Manoa. Bruce, the floor is yours.
Okay, thank you, Jose, ANACOM and the Portuguese government. Greetings and aloha from Hawaii. It's 3 o'clock in the morning here. Thank you for the opportunity to talk with you today about smart cables, especially in this venue that is celebrating the establishment of a major international gateway for telecommunications, while also setting the stage for a major advance in observing our planet and oceans for the benefit of society and the stewardship of the Earth. SMART stands for Science Monitoring and Reliable Telecommunications. The vision of the Joint Task Force for Smart Subsea Cables is to observe the oceans and Earth with a planetary scale network of sensor-enabled submarine telecommunication cables delivering tangible societal benefits. The Joint Task Force, or JTF, is sponsored by 3 UN agencies: the International Telecommunications Union, the World Meteorological Organization, and the UNESCO Intergovernmental Oceanographic Commission. About 190 JTF members from over 30 countries, representing 110 organizations, are volunteering their time and expertise to bring the SMART concept to fruition. The JTF mission is to implement telecom plus sensing subsea systems on a global scale to support climate, ocean circulation, sea level monitoring, and tsunami and earthquake early warning and disaster risk reduction. This will be a first order addition to the ocean and earth observing system. We will share the submarine telecommunications network that links countries and continents together, enabling our society and civilization. We will leverage this amazing living real-time network, 1 million plus kilometers of cable, several 10,000 repeaters every 70 kilometers that can ultimately host sensors, constantly being replenished with an engineering life of 25 years. Telecom is a primary mission with SMART secondary. The SMART portion of the system shall have no negative impact on the telecom portion. The basic sensors are ocean bottom pressure, temperature, and seismic acceleration. By better knowing the cable environment, we can better assure cable integrity. The orange circles represent first systems in development stages. The green circle represents CAM, underway in the Northeast Atlantic by Portugal with expected SMART capability. Jose Barros and others have introduced this in the previous section, and I'll come back to CAM on the last slide, leaving a more complete description to Yasser Omar, the next speaker. A number of other systems are in various stages of planning and RFP. The Smart Cables program is gaining momentum and needs support from all stakeholders to bring the concept to fruition. The program is audacious, innovative, and transformative, a perfect example of the blue economy within the context of the UN Decade of Ocean Science for Sustainable Development. Climate change is humanity's greatest existential threat. With smart, real-time observations, we will contribute to the Sustainable Development Goals of the UN 2030 Agenda and the Sendai Framework for Disaster Risk Reduction. And these SDGs are integral to the UN Decade of Ocean Science for Sustainable Development. We will contribute to the knowledge of climate change, including ocean circulation, heat content, regionally variable sea level rise, as well as mitigating the threats of tsunamis and earthquakes. At the same time, improving societal connectivity, the primary mission of cables, through improved cable integrity with awareness of their environment and network resilience, using knowledge of the environment from smart cables to better plan future cable routes, as mentioned by Pedro Tavares in the previous talk. This cartoon shows some of the components of ocean and Earth observing system. Satellites are crucial with complete global surface coverage. Smart cables will complement and augment other in situ elements such as Argo floats, DART tsunami warning buoys, providing for the first time comprehensive, deep ocean sustained observations. What do the three simple sensors, ocean bottom temperature, pressure, and seismic acceleration, tell us? Deep ocean temperature is increasing 50 millidegrees per decade. This is the red color down here. Ocean bottom temperature will contribute to better estimates of a heat content and thereby thermal expansion of seawater, leading to sea level rise, which is regionally variable. That's shown here. It affects ocean circulation on all scales and depths, and thus climate. Sea level is rising at 5 millimeters per year now, and projected to be 8 millimeters per year by the end of the century. There are extremely few time series of bottom pressure, and none are long term. Measuring the increase in ocean mass due to land meltwater through the pressure sensor will contribute to sea level rise estimates. And differential pressure across the basins and varying bathymetry will constrain ocean circulation. Water flows from high pressure to low pressure. Ocean bottom pressure and seismic acceleration will significantly improve earthquake and tsunami early warning. The red symbols on the map are earthquakes. Initial tsunami warnings based on seismic data will significantly improve earthquake and tsunami early warning. And pressure measurements are needed for reliable tsunami height predictions. This new seismic array will fill the large ocean area observing gaps, enabling a vast improvement of our understanding of Earth's interior. These first three simple, robust, and precise sensors and observations will provide a wealth of new and unique insights and pave the way for more. Let's look at the projection of SMART onto the UN Decade of Ocean Science. By leveraging the robust global telecommunications network, we will transform our ocean infrastructure, building a new platform for observing the ocean, complementing and filling in the huge observing gaps that we have and improving modeling. Smart observations of ocean bottom temperature and pressure support monitoring of the ocean portion of the atmosphere, ocean, climate, Earth system. Smart cable measurements of ocean bottom pressure and seismic acceleration will directly contribute to the early warning of tsunamis and earthquakes, saving lives and infrastructure, and to understanding sea level rise and thus informed mitigation of climate-related coastal flooding. Smart cables emphatically address Challenge 7, sustainable ocean observing. Within the decade, we have the potential of adding thousands of deep sea mini observatories, delivering real-time quality control data to warning centers and all users. Think global, real-time, long life, reliable, sustained, maintained, expandable, and with data managed according to FAIR principles, findability, accessibility, interoperability, and reusability. The fundamental technical goal of the SMART initiative is to make the SMART repeater a ubiquitous, off-the-shelf, mass-produced component of the submarine cable industry, routinely available to incorporate into any new system, and ideally most systems, for a modest estimated 10% incremental cost. There are several possible ways to mount sensors shown here. There are engineering issues to address, and they're all solvable. The first systems will result in a repeater that is warranted for 25-year life. Smart cables, as part of the global ocean observing system, will provide benefits for society, science, our stewardship of the environment, and the cable network itself. Smart cables is a perfect example of the blue economy with mutual benefit to all stakeholders. A modest investment will leverage the resources and expertise of this $5 billion per year telecom cable industry, represented here in the pictures. Suppliers are publicly acknowledging the great importance of climate change and their intent to include it in their corporate strategy, including providing smart capability. The Portuguese CAM system demonstrates demand. The equation is balanced. As Lino Santos said earlier, sensorization projects such as SMART will improve cable integrity and therefore their primary mission of societal connectivity. SMART data will improve cable routing and thus network resilience. Smart cables will continue its role of facilitation and coordination via program office. Via avenues within ITU, WMO, and IOC, the JTF will encourage adoption and implementation. Research and education networks such as GEANT, Red Clara, and NordicNet are stepping up to help. And we're working to involve development and investment banks and philanthropies. We continue to pursue now with regional systems with significant government involvement and funding. As noted, we need to be involved in projects early in the planning process. And we need to work with all stakeholders to advance the SMART concept to fruition. And we've learned, as everyone does, to keep it simple, KISS. This means both technically and politically. So finally, with the expectation that CAM will have smart capability, Portugal is an excellent example to emulate elsewhere. It has a history, Portugal, with submarine cables with regional and global connectivity expanding because of its positive leadership. I really want to acknowledge the support from the Portuguese government, ANACOM, and LEA in advocating and following through with the large-scale vision of connectivity with ocean and earth sensing included. It is extremely encouraging. Portugal, in an innovative way, is introducing the issue of the use of submarine cables for seismic environmental detection in the EU strategy for the creation of the EU data gateways platforms, thus expanding the scope of action of submarine cables beyond telecommunications. This is reflected in the EU digital strategy exemplified today at this conference with the EU Atlantic Data Gateway Platform. And SMART is an innovative way to contribute to this platform. With smart science and early warning as a modest, important, integral part, fully aligned with UN SDGs, telecom and energy submarine cables can enlarge their ambit and serve science and people together. In the UN Decade of Ocean Science, let's see SMART routinely being incorporated into new systems, providing the environmental data so needed for both missions, telecom and science early warning, jointly serving society. Thank you very much.
Thank you very much, Bruce, for your presentation. In fact, I have a question. How do you see the data flowing? Will it be freely available?
Yes, the intent is that it be freely available and follow these FAIR principles of findability, accessibility, interoperability, and reusability. In the Portuguese CAM system, as an easy example, there'll have to be an entity set up to routinely monitor the data from an engineering perspective and to assure that it gets to the appropriate national data center. Let's see, just a second.
So we are hearing you, Bruce?
Yeah.
Okay.
Okay. So there'll have to be a structure set up to make sure the data flows correctly, and that the data goes to archiving systems and raw data, real-time data goes to appropriate warning centers, including, let's say, the proposed system being set up for cable protection purposes. So yes, the basic principle is that data will be accessible to everyone that needs it.
Okay, thank you very much, Bruce.